Thanks for stopping by. When it comes to home automation, there can be many hazards. Please be careful when making modifications to appliances and interfacing into high voltage circuits. If you do not know what you're doing, you could end up electrocuting yourself, damaging your appliance, or starting a fire. Now that we have talked about the risks, let's watch the video. Okay, today's video is going to just be an overview of my smart air conditioner and my smart heater, and apparently the cat too. So this is just kind of an update on where this project is. So far we've been running these for the air conditioner for about 6 months. It's winter now, so it's not really used. And the heater for almost 9 months with the module that I put together for it. A few of the updates are the actual temperature sensor for the room, which is right here beside the alarm panel. Don't mind my shadow. So we'll pop that open, and we'll also pop open the front panel of the heater and the front panel of the air conditioner, so you can kind of see how that's set up. And we'll also go over the node red flow that controls everything. In my other video, I think the last video I made on this, we replaced the relay module, but I just had it shoved in the vent. So now we've got actually a slightly more permanent solution. So this air conditioner currently, all it does, it's completely self-powered in the sense that it's one AC cable, and the Wi-Fi module and everything is ran off the existing electronics. You can see my other videos on how we integrated it. But I've got a Amazon package cut up here, or a wrapper, to cover the module, which basically just sits right here under the flap. Very, very straightforward. It's completely electrical taped, just to make sure that there's no shorts or anything. But that's basically all there is to it. There's really not much to see. It definitely looks a lot more elegant, elegant to me with the bubble wrap installed versus just a hole. Plus also that protects it from the cat and other things that may want to come in contact with it. And that's basically how it sits, although that doesn't look as good as it did. I might have to adjust that later. So I've got two air conditioners that are both modified like this. So this is one of them. And we'll just walk over to my other upstairs room here. This one's not currently in the window, and it's a slightly different model, but it has the exact same modification done, and that usually lives in that window over there. And same thing, we've got the exact same heater in this room. So now that you've seen the air conditioner, let's move on to the heater. Just gonna grab a screwdriver. Okay, so don't mind these little white patches here. That's from when I put a bunch of holes in the wall and then tried to cover them and haven't painted them yet. So these heaters are actually not the original heaters I had. I switched them out because the other ones were what's called a high density baseboard heater, which means that it produces the same amount of heat as this does in half the size. But the problem I had with it is it vents out the top, and it was making my wall so hot that you couldn't touch it. And although they say it's safe, I don't actually truly believe it is. So anyways, we're just gonna pull this little flap off. And later in the video too, I'm gonna talk about some safety considerations if you ever wanna make these modifications, because this is, heaters can be very dangerous if they're used incorrectly. And the last thing you need to do is to burn down your house because you didn't know what you're doing. So I'm just going to turn up the brightness here, and I'll walk you through this. So this is a 240 volt heater. So in North America, all our power is, our wall power is a neutral and a hot, and it's 120 volts. There's also certain devices like this heater, for example, that uses two hots that are out of phase with each other to make 240 volts. So basically there's two 120 volt lines coming in here. These don't use neutral. So what I've got here is a Honeywell TCC module, and I say TCC because it's part of the Total Comfort Control System. And what it originally was a they include this little like wireless dongle that sits outside the heater and runs in and plugs into this relay module. And the wireless dongle connects to a wall thermostat. And that system was garbage, in my opinion. So I figured I've already got a certified device to switch the power on and off. I just need to somehow interface with this device here to make the relay latch when I want heat. So that's where this ESP module here comes into play. And again, it's heat shrinked and taped so that there's no shorts. And this is the antenna. I had to solder on a piece of wire to the ESP module antenna just so that it would stay connected to my Wi-Fi due to the little plate here that covered it and basically completely blocked out the signal. Anyways, so quite simply, this module is running Tasmota, and I got really lucky, and I found on the bottom of this module, and it's really hard to see. I got another one of these, so I'll show you what it looks like up close. But anyway, there's a multi-pin connector at the bottom there, and it provides 12 volts of power, and if you just short two of the wires together, the relay turns on. So not only does it switch my heat on and off, it also provides power to the ESP module, making this a very, very clean and simple setup. So that's basically this. I'm going to pop all this back together, and then we'll look at the temperature sensor. So this is my temperature sensor, and it came from, the housing came from AliExpress. I got a whole whack of them for my multiple projects, and all it is just basically a little plastic wall mountable case with vents on the side. I'm going to pop this off very carefully because I've got a little piece of cardboard in there that probably will fall out. Oh, apparently the cardboard isn't even in here anymore. Okay, so let me walk you through this. There's a few aspects to this, and I know this looks pretty messy because this is kind of this was my prototype, and it still is not the final revision. I got a Wemos D1 Mini in there, and we've got an SHT30 temperature sensor. There's a couple extra leads coming off here because, again, it's kind of the prototype, and I've modified it probably 3 times already. I got a buzzer in there that's hooked up to a pin on the Wemos as well, so that I can use that for alerts or warnings or whatever. However, there was a large problem with this setup, and that's the fact that when the Wemos is powered up for about 5 minutes, my temperature readings start to climb. And after a bunch of research, I found that I am one of probably hundreds, if not thousands, of people who have tried this setup and had problems with it. So my solution was to take Tasmota off this and load it up with ESP Home, which I found a lot easier to work with for this purpose. And we're using a deep sleep feature. So basically it sleeps for 30 seconds, wakes up for 5 seconds, takes the reading, and then goes back to sleep. And that's actually been able to stabilize my temperature readings quite well, actually. One thing that to note, you have to have one of these, the reset pin soldered to one of the digital pins in order for the wake up to work. That wasn't really super obvious to me when I first started, so we had a few problems with that where it would just go to sleep and never wake up. So this one's a little bit messy. You can see that it's hot glued in. There's a Cat 5 running downstairs to my basement, which I'll show you after. You saw it just flash there. That means it just woke up. The same Cat 5 is running the alarm panel because this uses four wires, and then I've got 4 extra wires, so 2 extra pairs here available. So I've got 2 that aren't even in use for future projects. And then of course the buzzer is completely non-usable because the module is sleeping most of the time. So if I need the buzzer to go off, I have to wait for it to wake up. So not really applicable yet, but I plan to take out, redo this with another revision, and fix this temperature problem, because I also want to add a TVOC sensor in there, so I can get my my TVOC levels and ECO2 and stuff up here. You may wonder why I have a shield that's separate from the Wemos, and that again goes back to the temperature problem. And I tried separating them to fix the problem, but still was not far enough. I've read that if you use 10 centimeters of shielded cable, which is about like this, you can get around that problem. I'm not super clear on the technical reason why the sensor reads too hot, but that's the solution that was suggested. So both my upstairs rooms have one of these. This one's pretty nice because it's doesn't have any wires going to it because I was able to jump off the alarm panel. And over here in my other room, this one's a bit of a problem because it's too far from the heater and it's kind of buried in a corner and too low to the ground and a whole bunch of other things. So it doesn't read adequate or correctly for the room. But it's literally the exact same setup, except for this was version 2 and this one has the TVOC sensor in it. And this one does have a piece of cardboard in there because I stupidly mounted the temperature sensor on top of the module instead of below. So what happens is the heat rises up from the module, which again is insignificant, but it seemed to be enough to cause that, along with the short wiring, temperature sensor reading problems. So this is just wired in through my network jack, and there's just a power supply sitting in the basement that that runs this. And this one's actually got the TVOC sensor in it, and it's hooked up, and it does actually work if I leave it powered up, but it also sleeps and only wakes up to send the readings. So I'll pop that guy back on. If I should line it up, it might work better. There we go. So that's kind of a long explanation of my temperature sensors. They also, of course, read humidity. And let's go look in the basement. Super messy server rack. Yes, it's a kitchen island. Here's my very old server that runs basically everything. And we got my 2 switches, PoE switch on top, and then just standard gigabit switch on the bottom. So let's just quickly, I'll show you how my modules are powered. So I've got this funky thing right here, which is, first of all, powered off of PoE. And it's just a Arduino, a modified version with built-in Ethernet shield. And this runs all my temperature sensors. This was originally running all the DHT22s that were around the house remotely, and then I switched them out for the WeMOS with the SHT sensor, just because I was having issues with the long cable runs with the DHTs. So they're all still powered off this, but a lot of them are not actually using this module to report sensor data. So only my basement sensor and outdoor sensor are still active. And here's my basement sensor, just to give you an idea of what it looks like. Yeah, so that's powering all my modules, except for that one room upstairs that was plugged into the patch here. And that one is, actually, let's see if we can find it here. So this is it right here. So it's plugged into 10, which is the jack on that room. And I've just got it connected to a USB cable. And that's actually powered off my camera DVR right now, apparently. So that's running that one. And let's quickly talk about the modules and the heaters. So this is the Honeywell system. That's the piece that's supposed to attach to the side or attach to a junction box. And this is what the actual relay module looks like. Here, let's flip this so you can actually read it. So this works with 120 and 240 volt systems. So it's a switching power supply in there. I did pop one open, and it's just a little bitty transformer and all the electronics to make that work. And then I just modified this plug here, and basically there's a ground, a plus 12 volt, and then one of the pins controls the relay. And that's what this is. This is the wireless receiver for the Honeywell system, which also talks to the RedLink module, which I absolutely detest this system. I might make a video on it. But my main floor still has a Honeywell thermostat, so that'll be the next task. But unfortunately, it needs to actually have a wall interface, so I haven't switched it over yet because it's phone only is not really an option, apparently, so I've been told. Anyway, so that's kind of the way this looks. And this is actually the thermostat right here. This is a Windows Server 2012 hypervisor that really needs to be cleaned. This is also running Plex and file storage. It's got, I think, 10 hard drives in it. It's a dual CPU X5460, so it's pretty dated, but it's running Node-RED within Windows, and it's also running Has.io in a VM. Yeah, so why don't we go look at the configuration of that, and you can see how it works on the software side of things. Second time doing this video because my microphone cut out, and I'm not really equipped to do a whole bunch of takes and editing and all that stuff, so we're a one-take kind of situation here. Anyways, let's look at Node-RED and kind of how I control my heating and cooling upstairs here. So here's Node-RED. This is my GUI that I've set up for the heaters. Let's start by going over here. You can see at the bottom here the blue boxes when they go up. That's how I know the heat is on. This is just a really quick modification to the default history graph in Node-RED just to let me see what's been happening. And up here you can see the temperature, and then you can see it's maintaining the temperature here. You can see that's actually a pretty stable line there. So with all the tweaks I've done and all the ways I've set up that I can control and fine-tune the way the system heats, I've been able to create a fairly stable temperature. So we'll go over here. This is pretty straightforward. We've got off, heat, cool, or auto. Auto will choose whether it should be heating or cooling, which, I mean, that should be self-explanatory. But let's just talk about auto quickly and how it knows. So if we go down here and look at the thresholds I've set up, you can adjust when the system will switch between modes. So if it's currently heating the room, and let's say it's hit its target, but for some reason the temperature starts to go above the target. So let's say we set our set points 18, and it's heated the room up to 18, but now for some reason the room's getting hotter. If it goes over by X amount, which is set here, we've got it set currently to 1 degrees Celsius. So basically, if it hits 19 degrees, the air conditioning will kick on and start cooling the room. Same thing if it's the other way around. So let's say the temperature is set to 18 and it's a really hot day out, and the room has been cooled to 18 and the AC shuts off, but all of a sudden an Arctic spell comes in and cools the room to the point where we'd all be freezing to death. Well, then you want your heat to kick on. So if we go down by 0.6 degrees, so our set point's 18 and the temperature drops to 17.4, the air conditioning will automatically kick on and the heat will kick on and start heating the room until it hits its target. So that's how the auto threshold sets up. Originally I just had it at a fixed number, but I realized that I wanted to be able to tweak it quite easily without actually going into the flow, which I will show you in a few minutes here. So let's also talk about when it decides the heat is satisfactory or the cooling is satisfactory, and that's where we have our hysteresis settings. This, again, should be familiar with should be somewhat self-explanatory for anyone that's done Climat before. Right now, it's very straightforward. We've got, so when you're in cooling mode, and this also does apply when it's in auto, when it is in auto, it still will choose whether it's cooling or heating, and then it will look at these values. So if you're in cool mode and your target's set to 18 degrees, it will not engage the air conditioning until it's 17.9, and it won't turn off the air conditioning until it's 18.1. That way it stops your heater or your air conditioning from rapid cycling. Same with the heat. Now, currently, this is set up in a very cool manner, no pun intended, that allows the values to change depending on the outside temperature, and that's why I've got these auto buttons hooked up. So, as an example, let's say it's 6.7 degrees outside right now, which is not very warm, but if I want to heat the room up to, let's say 24 degrees, that's quite hot in comparison to the outside temperature. So what will automatically happen down here, and we'll see it populate or update in a few in a few seconds, or actually minutes here, I guess. I don't remember how often it checks. But what it should do is adjust this to 0.2 or 0.3, depending on what I've set it at. Again, I haven't looked at it in a long time. So that it doesn't rapid cycle, because the outside temperature will affect how long the room will stay warm. And since this is a very old house, built over 100 years ago, the insulation is not great. It has not been updated. So I want to be able to heat the room above or a little bit warmer, so that the heat the heater doesn't just kick on right away. So as you can see, it's gone up to 0.2. But if it was colder outside, let's say 0 or -10, -10, I believe we'd probably be at about 0.5, just because the warmth would just disappear so fast. Don't mind all my ums. I'm just trying to remember everything as I'm talking, because again, I'm not a professional. I'm not scripted. I'm just doing this on the fly. So same thing applies with the cooling. So if we're really hot outside and we're trying to cool significantly lower than the outside temperature, this will increase and cool the room slightly colder than it would normally. This has worked really well, and I've tweaked it throughout the summer and winter so far to try to maximize efficiency and stability of temperatures. So that's kind of explains that there. Let's talk about my air conditioning and how I control the fan speeds. So the heat is quite simple. It's on or off. The air conditioner has 3 different fan speeds. I'm just going to silence my phone. And the way that works is we've got a differential set up down here, and we've got a way to turn on auto fan speed or turn it off. So if I turn it off, I can just choose a speed. If I turn it on, it'll automatically choose a speed depending on where we are and how far we are from the cooling target. So I definitely don't need air conditioning today, but we're just going to turn it on anyways, just so that I can demonstrate this. So the air conditioner just kicked on, and you'll see the fan speed selector has gone to medium, and that's because we are over 0.5 degrees away from our set target. In fact, we're over 1.2 degrees. So what should happen once it checks again to make sure it's in the right speed is it should actually bump the speed up to fast, or high, which is the fastest setting. So the way this is set up is it'll automatically choose low if it's just maintaining the temperature. But if it's actively cooling because the temperature is too far off the target, it will use one of these settings. So let's say our set point is 17 and our temperature is 20.2 or 20.1. We should be in fan speed 3 because we're over 1.2 degrees away. And now let's say it's 17.8 in the room, but the target's 17. Sorry, that doesn't make sense, because that would still be fan 3. So if let's say it's 17.4 in the room, and the target's 17, it would automatically go to the fan speed 2. And this is adjustable, and I've adjusted it a few times just to my liking, but I'm not quite fully happy yet. There we go. So you just switch to high. So let's go. Let's say 19.5. So now we're 20.1 in the room. Actually, let's just go to 20. Let's see if that stays on or turns off. I don't know how close it is to the target. It should theoretically stay on until it hits negative 0.1 from the current temperature. So it should stay on until it hits 19.9. And you'll see the fan selector now should go down to low. So this makes it so when I'm first cooling the room, so let's say it's 9 p.m. and I'm going to go to bed at like 10ish, maybe 10:30, and it's a really hot day. It's easy. My rooms upstairs easily get to 20, 28, 29, 30 degrees Celsius in a hot summer day. So basically this allows me to use the high speed on the fan to try to get that temperature down quicker when it's that hot. And then this way, once it gets closer to the target, it turns the fan to low. That way I'm not dealing with a whole bunch of unneeded racket from the air conditioner fan. So hopefully that makes sense. I'm sorry, I'm a little bit rambly when I talk about this stuff, and it may actually be completely boring, so you're also welcome to turn off the video if you don't like it anymore. But anyways, moving on. Auto fan is very self-explanatory. When that's turned on, the fan will just shut off when the cooling target has hit, and turn on when it starts actively cooling. When it's off, the fan just runs on low the whole time the system is in cooling mode, unless it starts actively cooling and the fan picks up speed for whatever reason that may be. Any questions, definitely comment, and I'll do my best to answer them. I will also try to share this flow for anyone that is interested, although it's very complex. It might be hard to adapt, but there's lots of good stuff in it. So another thing with the air conditioner is I'm going to turn it up to 22 so that it actually turns off. There's something that happens to air conditioners if you turn them off and turn them back on again really quickly, and that's the compressor fails to start because it's under too much pressure. So I've got a cooling weight built into this system that will automatically wait 5 minutes, I believe, before it will turn back on the air conditioner. So in this case, you can see it's just switched to compressor delay. So it will take its time, and that way the compressor is protected, and the air conditioner will start up again when needed. And yeah, that's about it. All right, continuing. Someone was at my door. Anyways, so I'm just going to talk about how I make sure that the condenser doesn't freeze up. Because what happens is if it's colder outside, let's say 12, 13 degrees, the air conditioner becomes a lot more efficient. And because we live in such a high humid area, there's a lot of moisture in the air inside. And what happens is that moisture, when cooled, starts to turn into an actual liquid, and then it freezes up on the condenser. So I've had instances where the entire front condenser is frozen so solid that no air can pass. So anyways, I came up with a solution that looks at the outside temperature, and if it's, I don't remember exactly what the values are, but basically there's two levels. There's one that'll pause the cooling for, I think it's every 10 minutes, it'll pause for 5 minutes, and that's if the temperature is like below 10 degrees. And yes, I know we should just open a window and use a fan. And then if the temperature is below 20 degrees, I think it pauses every 20 minutes for 5 minutes, just to make sure that no ice has started to build up. And that's basically been 100% effective since I did that. So that's basically how all this works. Let's just talk about how we make sure that everything is working safely in case, for example, what happens if node red turns off or crashes, and the air conditioning is currently on or the heat's on. How do we make sure that we're not wasting power and causing potential for a electrical problem? So quite simply, let's talk about cooling first. The way the relay board's set up, the number one concern is the compressor turning on without the fan being on. So I've made it so that whenever the compressor is on, the relay also will feed, the compressor relay also feeds power to the fan relay. So the fan has to be on no matter what. But the fan relay also can still turn on independently, so the fan can run even though the compressor is off. So that protects me from freezing up my air conditioner and building too much pressure in the cooling lines. So what I've done with both the air conditioning module and the heating module is I'm using something called pulse time on the on Tasmota. I should have brought this up already. Let's see. I'm just gonna remember where. Here we go. So let's bring up. I want to say 51 is the air conditioner. Just give me 1 second. I've also password protected these just so that if someone's on my network and finds them, they don't go in there to mess around. So here we go. This is the air conditioning, which again is wasting power right now because I definitely don't need air conditioning. But you can see, so this is the compressor. This is fan 1, fan 2, and fan 3. I've used some clever wiring to make that all work correctly without accidentally turning on 2 speeds at a time, which would be, I tried it. It made some terrible noises, so I stopped quite quickly and decided I needed to figure out a way that couldn't accidentally happen. So if you're interested in that, comment and I'll try and explain. So anyways, so we use pulse time to make sure that nothing stays on if node red crashes. So currently it's set to 300 seconds and we're at 248 seconds. So what my flow does is it'll send an on every X amount of seconds, basically operating as a dead man switch. So similar idea. Well, I got the idea from they do it on trains, so that if something happens to the conductor, the train will stop. And by conductor, I mean engineer. So every certain amount of time, he has to push the button, or else to say everything's good, or keep going. So I use the same technique here. So node red is essentially pushing the on button. I think it's every 1 minute, and that keeps all the relays running. So pulse time, it's set up, you can see that it's happening here. So that's the fan there that just came through, and this is the compressor. They're just slightly out of sync because they turned on at different times. But yeah, so what happens is if node red is shut off, what'll happen is this will just hit 0 and everything will just turn off. Literally the heat is exactly the same. So if I bring up the heat, the pulse time should actually be at 0 because it's not currently being used. So you can see there it's set to 300 seconds and it's currently at 0, which means the heat should be off. So that's how I make sure that if node red crashes, we don't have a big problem. I originally had it set up so that if it disconnects from Wi-Fi or MQTT, it would do the same thing. It would just shut off the relays, but that does happen from time to time, and I was getting my stuff shutting off when I don't want it off. This was a much better solution for me because this is independent. So if Wi-Fi shuts off, if it loses its connection for even like a minute, it'll come back, and we won't have any interruption in the heating and cooling unless it's down for more than 300 seconds. Hopefully that all makes sense. You can see here now fan speed 1 is still on and everything else is off because we've hit our cooling target. So we're now idle. So let's look at the flow. This is, I started basing it off of a few flows I saw online. I also tried to use the MQTT thermostat here, but it honestly just sucked. It didn't do what I wanted it to do. It wouldn't give me any sort of elaborate options, so I decided to do it all from scratch. So I'll try to share this, but it's quite there's quite a lot to it. There's also HomeKit nodes in here for controlling it from iPhone, as well as fully controllable through MQTT, which is how I have my Home Assistant interfaced. So just a quick overview, this is kind of the logic here that defines when things should turn off and on and all that stuff. We got our antifreeze in there. We've got our compressor weight and delays. We've got our status window, which basically has a script here that will show the different statuses. Yeah, that's this is a whole video on its own to walk you through this, but this basically controls everything. So I've got one copy for my bedroom, one copy for my office, which is the room I'm in now, and then soon there'll be another copy which will be heavily modified for my main floor since it's a furnace. And then through MQTT, I've got that linked into Home Assistant, which runs just a whack of automations. But you can see here, well, it's all over the map because I've been adjusting it, but this will also show the history, which is kind of nice in Home Assistant. So that's basically the software end of my climate control system for upstairs. A lot of time and thoughts were put into it. You can see this room, for example, is way hotter than 17.8. This is the room where the thermostat's behind the shelf. I've got this is actually the old wireless baseboard heater thermostat, and you can see, oh, that's not put it in front of the mic. You can see it's 21.5 in here, which feels accurate, but it actually thinks it's 17.8 because it's stuck in the corner there, no airflow, and that's an outside wall, which is not very well insulated, so it's reading quite low. So that's actually going to be my today's project to fix that. A few other fun features. For example, the air conditioning is not on or in the windows in this room, so it shows it's offline. This shows me my uptime since last rebooting the module. We'll go over here, same thing. AC's, well, the heaters are the same because when I turn off the breaker, they both turn off. AC uptime, 54 days. That's probably since the last time, I don't even know why I unplugged it. But anyways, yeah, so it's been a very reliable system so far. And hopefully this can help someone trying to do the same thing. Yeah, so until next time, that's my do-it-yourself smart heater and smart air conditioner.